So hi there. In this video, I'm going to go over the PictureLab. You see that I have arranged the classes in the PictureLab, the classes and actually one interface in PictureLab more functionally than I provided them to you. They're all just jumbled up. So let's just go over this at the sort of why I arranged them this way. Color chooser, int array worker tester. These are just files for you to explore and to review things. So if you don't understand how computers handle color, take a look at color chooser. You can learn a lot from this little program about how computers handle color. These two programs are just go over two-dimensional arrays and working with two-dimensional arrays using nested loops. And if you're feeling like you need a little work on that, definitely take a look at these. These four all have to do with the APIs, the application programming interfaces that Java uses to handle screen elements like windows and menus and mouse movements and things like that. So totally outside the bounds of this course, but feel free to look at these if you'd like. Yeah, you could learn a lot from exploring these. So these are the classes we're going to focus on, and that the PictureLab focuses on. We'll start with this interface, digital picture. So this is a typical interface, right? There are no fields. And we have a bunch of methods declared, but with no definitions of them. And they're the type of things that you could do with a digital image. I'm not going to go through them. But so this is sort of a very abstract view of a digital image and the things we might want to do with it. I'll just mention that buffered image is the class that Java uses for handling an image, and so that's where the image is actually stored behind the scenes. So any class that implements this interface is going to have to actually define every single one of these, fully define as working methods, every single one of these method headers. I know this could have been done as an abstract class, and then we could have had some fields here, which all digital images are likely to have, things like width and height and title and things like that. The advantage of doing it as an interface is that this then becomes something that could be inherited by a class in addition to, or extended by a class in addition to inheriting from other, implemented by a class, sorry, is the correct term, implemented by a class, as well as that class extending other superclasses. So it gives you some flexibility in inheritance, allowing multiple inheritance. So let's look at Pixel quickly. So Pixel represents a single, it's a class that creates objects, that allows you to create objects that represent a single pixel, right? A single picture element on the screen. And things that you might want to do with that picture element are get its location, get its alpha value, get its red value, get its blue value, etc. And obviously to set those things as well. Okay, now for any image that we're likely to use, there are going to be a lot of pixel objects, right? Because it's the number of rows of pixels times the number of columns of pixels, right? So if it's 1,000 by 1,000 1,000 rows by 1,000 columns, that's 1,000,000 pixel objects. And the computer will happily create those very rapidly for you. All right, then simple picture implements digital picture. So that means that it's like made a contract with Java that it will make complete versions of all of the methods that are listed in digital picture. So this is not an abstract class. Could be. We could add that extra step here, but this is actually a class that goes and doesn't have any abstract classes, fully implements all those methods. Okay, and I wanted to just go over some stuff here, starting with we'll do this, starting with about here with getPixel. So what this will do, getPixel will return a pixel object. So it will make a new pixel. This, by calling an object, or by creating a new pixel of the pixel class, passing in this, which is a reference to the simple picture object that's making the call, right? And an X and Y position, and it will return a pixel object that was created. And you can go and look at the constructor of pixel and see what that does in the pixel class. So here we have one that returns a single array of pixels. And what this will do is it will get the width of the picture, get the height of the picture. That's this simple picture object, right? We could write this.getWidth and this.getHeight here, because we're talking about this object. And then makes a single dimensional array called pixel array, which is, as I said, is the width times the height of the image, right? So of any, other than a small image, this is going to be a pretty big array. And then to actually move the images from the image, right, which is a two-dimensional array basically, into a single-dimensional array, we're going to have to go through the rows and all the rows and columns of the image, making a new pixel from each one, and adding them to to pixel array, all right, and then returning pixel array. So here's one that will create a two-dimensional array of pixels. And in this case, it's a little bit more straightforward, right? We're just transferring from the image, the buffered image, basically, over to this two-dimensional array of pixels, mapping column and row to column and row, right? And then returning that two-dimensional array of pixel objects. And so, so that's the main stuff I wanted to go over here in this brief introduction. Now, Picture is simply a class that extends Simple Picture, so it has all of Simple Picture's methods, and it adds some more. This is actually where you're going to be doing most of your work. You're going to be adding methods to this class that will manipulate arrays of pixels, or two-dimensional arrays of pixels to manipulate the image. You'll be calling those methods from Picture Tester. Picture Tester already has some methods that you can play with. And then you're going to be, over in the picture class, you're going to be adding these methods. And as you add them, you're going to be uncommenting them. So this way you can, go nice and sequentially and make sure something's working before you go on to the next thing. And you'll be able to know, exactly. If you uncommented all of these, then you'd have getting all these error messages because these haven't been created yet. So this way you write one method, you uncomment the call to the method, and then you test it. Okay? So that's an overview. I would say if you want a better understanding of how computers handle color, start with Color Chooser and just play around with it. Experiment, see if you can figure it out. If you're feeling weak about two-dimensional arrays, spend some time playing with these to get reviewed, and then make sure that you've got an understanding of these. You may want to look through them, and then start working on those methods in Picture Tester that PictureLab asks you to do in the exercises. Okay, thanks.